Besides the antivirus engine itself and antivirus product itself, a very important part of a whole process of malware detection and prevention is to have malware analysis lab. And malware analysis lab is usually a team or multiple teams in a company who would build a lab where malware both harvested, the new malware is harvested, and also analyzed to write a signature, right? Because you cannot just assume that every single virus or malware will be sent to you by a customer, because for this, customer need to first find the malware itself, and it means the customer already like this patient zero is already gone, right? And usually you try to prevent an attack from happening as early as possible, instead of waiting for customers to report malware, especially in the days where some worms would spread in a matter of days on hundreds of thousands of machines. That's what Malware Analysis Lab would do. In 2000, 2005, there was early Malware Analysis Labs. Of course, that's the same lab where virus analysts would analyze malware manually and write the signature, but there was some automation already available at that time. First of all, to harvest and collect new malware samples, people would use worm honeypots or email and email honeypots. It could be the same machine, it can be separate machine, but the idea is the honeypot is the vulnerable server which set up purposefully with a weak security posture in mind. So it's pretty much vulnerable to anything you know at that point when you set up a honeypot. And it's also not used for anything except being a honeypot, meaning every connection you observe to it is potentially a new malicious connection. And for worms, it would have IIS-5 or any other software which is potentially vulnerable and exposed to internet at that point of time. So when you see something connects to it, it's either some scanning or some attack against the server, because again, it's not used for any other purposes. And the email honeypots would be designed slightly differently. People would create email accounts and spread them in the open forums or post from them, assuming that the spam actors or email worms would harvest that account and start sending the worm or the spam to that honeypot accounts as soon as the infection starts, because that would be like in everyone's list, that email, and this email would not be used for benign purposes. So it means every email you receive in that inbox is automatically either spam or some sort of malicious activity. Besides harvesting, there also already would be an early effort to do automatic analysis and automatic detection of new malware samples. It wouldn't be mainstream, it wouldn't be like high scale systems yet, but I have to give people a credit. They're already thinking about this. While I was fact checking for this episode, I found a lot of virus bulletin articles from 2001, 2002 about these first attempts of automating malware for Win32 and also automating unpacking. And so just to give you an idea how a simple early behavioral analysis would look like, because I think it's pretty cool. It's a predecessor of sandboxes. So the very funny thing is that security expert would use a DLL sideloading, the techniques which nowadays and through the last 20 years malware constantly using as well. But the idea is that if you put the DLL, the way the load library and the Windows loader searches for DLLs to be loaded into the process is to first checking for current directory and then checking for system directory. Meaning if you put a fake kernel 32 DLL and fake NT DLL into your local directory and run the process, it would actually load a fake NT DLL and fake kernel 32. And what I mean by fake, it's DLL you developed and you implement some expert which you call exactly the same as NT DLL experts are called. And inside this expert, you would implement logging or certain emulation of behavior, because of course you couldn't just rewrite the whole Windows. You also don't want to use real NT DLL and kernel 32 because that exposes to potentially lose control of the virus, even though you would still execute it in a closed environment, either in the early virtual machines or on actual physical hardware. People would use just physical computer to do that. When P files start to execute from entry point, it would execute the code and then would reach first API and this API would go, instead of going to real NTDLL, because real NTDLL is not loaded, it goes to yours. Here's your code which says, okay, log it, and you log API 1, and then when malware calls next API, right, your system again would log API 2, and so on, right? So at the end of the day, you would have a list of different API executed, and of course this would only work to the extent you implementing the fake APIs, because as soon as you hit the API which doesn't exist in your DLLs, the loading of that PE file would fail, or also because you're not really implementing the API the exact same way it works in operating system. In most of the cases, you don't implement the API at all. You just implement logging and some very basic emulation of, hey, most likely that API would return that buffer and that return value, meaning most likely at some point that PE file would just crash, right? Because that was some unexpected behavior that crash. The idea is that to implement enough APIs that by the time it crashes, you already see behavior enough to classify it as a malware. And of course, if you see something like this, it doesn't need to be perfect. It's all running in the malware analysis lab. That's just to prioritize new potentially malicious files for manual analysis. At that point of time, no one was creating signatures automatically. It would be just a lab where you run whatever files you receive either from customers or honeypots or anywhere else, and run it through that system. And if it looks like it's potentially malicious, you would prioritize it and look into it and start analysis. A similar system would be used to do universal unpacker. Imagine a new packer, and even though it might be not very difficult to unpack, still implement unpacking will take you a week, 2 weeks, 3 weeks. And meanwhile, malware can use that packer, meaning it can spread, and your signature is going to be very inefficient because you can only create a signature for packed samples. So while you're developing and unpacking in your lab, you would run what called universal unpacker. Would be very similar system, right? You're trying to run a sample as far as possible until it crashes, but still keeping it under control, and then dump the memory of that sample and analyze it and see, okay, does it look as a known malware? So what you could do is you can unpack it and then dump the memory and then apply existing signatures you have. And if you say, okay, it's known malware, but it's packed by a known packer, we need to take care of it. First, we need to, again, develop the unpacker, and the second, we probably need to create some temporary signature to at least detect that specific sample. And of course, since you have a memory dump and it's in the lab, it doesn't need to be super fast. You can also do a string analysis. Usually the way API imported into the file is by having import table where they're available as a strings, right? The names of APIs will be available as strings. Some other interesting strings like a parameters might be available inside the binary. So if you scrub the strings and then apply some heuristics on that, you could recognize some potentially malicious behavior, and again, virus analysts would look into it, develop a signature, or whatever needs to be developed. So it's very early prototypes of sandboxing. It's yet not a full sandbox, but it's kind of sandboxing. The unpacking systems and also string analysis. We're going to talk a lot more about this in the upcoming episodes, but I just want to give people in 2000s a credit. They already have, at least some companies would already have systems like that developed.